Hi, I'm Bryan with Pioneer Builders. Welcome to this episode of Build Show Bryan Talks. Today we're going to talk about hot water in a house. Let's dig into the details. One of the modern conveniences that we have in our homes is hot water. I mean, just think for a second back in history what it would take to have hot water inside your house. Now, to be honest, in the past, you would probably have, it's horrible to think about, slave labor, servants, and then as history progressed, maybe it was somebody who lived like Abraham Lincoln in Illinois. What would they have to do to get hot water? They would literally have to work probably splitting firewood, and maybe they would only have a bath once a year, or once a week rather. Once a year might be a little long. But just think again of the energy involved. So in order for us to move, we're digesting food, we're getting that energy that we're able to use, cutting down trees, splitting firewood, then really that's like locked in energy. It would have to combust, and it would have to combust enough or burn in order to produce enough heat to heat up that water. Just massive amounts of energy, and not only energy, but think about the amount of time that would take in order to have hot water for use. What are the benefits of hot water? Well, it's very nice to wash your hands in warm water. Hot water also helps to keep us clean. Taking showers regularly, diseases go down. In fact, when it comes to the building code, plumbing is one of the most important parts of the building code because of how it directly impacts human health. So there's convenience, there's health, and we may not think about water that much. We might get used to how our houses behave and just make occupancy changes. So for example, we've got a hot water tank, most of us. We may have a tankless unit, but in either cases, I like what Eric Ani said. The hot water tank is just kind of like part of the piping system. It's just a huge pipe when you think about it that way. So we've got piping that's got a diameter to it, it's got a length, and then it hits this huge area that could be 40, 50, 80 gallons. It could be connected with another tank. Again, we could have a tankless unit, but what's happening? What we're doing is we're feeding water to that tank, and instead of having to burn wood or something like that, there's some other input that changes the characteristics of that water. So we have heat pump water heaters in the houses that we build. So you could literally be using heat pump technology to transfer heat from the outside into that tank, raising the temperature of that water. You could use resistance heat. Again, you have an input. In all of these cases, there is a means of changing the characteristics of that water. You could have electricity going into the water tank, and through the action of resistance, you create a temperature change, and that transfers heat to that water. You could have a gas-fired unit. Again, that could be a tank unit, it could be a tankless. Tankless units could even just use resistance heat, although that's a tremendous amount of energy if you're going to go that route. But just as you have a stove that can have a burner, you can literally be cooking your water. So we're sort of using the same combustion, but instead of, again, from firewood, something of that nature, we're getting it from a municipal source or a utility company in order to heat that up. So that's how we're getting our hot water. Now, how does that get to the tap? We just have a series of pipes that gets it there. It's under a certain amount of pressure, a certain amount of PSI, which can be different depending on where you're at. One other thing to think about is the water can be coming from a well. It could be very local, or it could be a municipal supply. So there's quite a bit that comes into the distribution on that side. But we have the cold water that comes into a hot water tank. That's what we'll use in this talks that we're giving. It treats that, and then it comes out and distributes throughout the house. Now, oftentimes what you'll see is basically a a branch and chain, or basically there's a main line that can come out and then you branch off from that. And you feed each of your different fixtures. So you'll probably have a hot water tank at your lavs, your sink. I would imagine lavatory comes from like laver, if you know Spanish at all, about cleaning. You'll probably have hot water at least at your shower, your bathtub, and the diameters are all different depending on what you're going to be using. You'll have probably hot water that goes to your dishwasher, your washing machine, your kitchen faucet. And as you think about all that, and you're adding all of these fixtures, you're adding length of pipe to all of that. There's another part of these resources that we need to think about, and that's the water itself. So in certain parts of the country, in the United States, there is a dearth of available water. And the problem's only getting worse. So now we're seeing where different disciplines tie in together. We've got the electrical side, or the gas, or the propane, but then we also have to think about the water that we want to save. So I was just on vacation, and we live with low flow plumbing fixtures personally. Water conserving or water saving sounds a little better than saying low flow. To me, it's just a words thing. Anyway, we stayed at a house that did not have low flow fixtures. And I'll tell you what, it was like you're creating a flood. When I would turn on the kitchen faucet, it was a perceptible difference as to how much water came out of there. So you might be used to thinking, or you've heard the expression GPM, or gallons per minute. Over time, what has happened, in order to save water, in order to conserve water, because it is a finite resource, we have lower flows that come out at the tap. So imagine if you're pumping out 5 gallons per minute, we're just going to make this real simple. If you had a 5-gallon bucket, a paint bucket, that would fill up in about a minute. That's an incredible amount of water. But and we'll talk about this more in another video. But if you reduce how much water comes out at the tap without a loss in serviceability for the user, it's a win as far as conserving water. But where do you lose? You lose when it comes to actually having comfort and how long you have to wait for that water. So it's a function of pipe diameter and pipe length for how long it takes to get water from your water heater to the point source, to where you actually need it. So if you're pumping out 5 gallons per minute and you have a very limited amount of water, maybe you've got a shorter distance, larger diameter, you're going to get hot water pretty quickly. Everybody's happy, except the water company, because we're going to be using so much water to flush out that line. Maybe I should amend that, especially if your plumbing fixture is a long distance away. So you'll get the hot water faster, but you'll be using more water. What are the solutions? Really, everything in life comes down to having a happy medium. And so you want to pay attention to your pipe diameter. And if possible, you want to have your point source usage for those plumbing fixtures closer to the tank. That's in a perfect world. In a perfect world, if you could design a plumbing core to keep your distances small, you keep your diameters the minimal amount that they need to be, you're going to be able to get hot water faster. But that isn't always realistic. In your design brief, that just might not be how the people want to live. You could have a sprawling ranch. You could have a large building. There's just no way that you would be able to accomplish what you're trying to accomplish just with plumbing design in every case. So what's another solution? Having a pump to recirculate hot water throughout the house. And we'll get into that on another video. Well, thanks for watching this Build Show Bryan Talks on hot water heat. Thanks for watching. Follow me on Instagram. That's where I really cover a lot more of the day-to-day operations. A lot of good content on the Build Show Network, and we'll see you next time.